Earth, on this beautiful blue-green planet, a long history of many living things has been written in time. There are clues to explore a part of that active life. They are the layers of sediment which have accumulated on Earth recording its history. Quietly continuing to make the passage of time, these extraordinary layers of sediment, attracting attention from around the globe, have become the standard timescale.
Hello everyone, I'm Nyanko, famous for my stripes. In Fukui Prefecture, where I live, there is a world-class lake. What makes it world-class, you ask? Because it's a lake which has the greatest banding in the world, just like my stripes. Now, let's go and take a look at that banding. We are at the 5 lakes of Mikata in Fukui Prefecture. The largest one is Lake Suigetsu, the lake that has the greatest banding in the world. So, where is that great banding? It's at the bottom of the lake. Various things have piled up at the bottom of the lake over a long time. Let's take a closer look. You can see the striped pattern easily, right? This is the banding of Lake Suigetsu. The stripes are known as varves, and each layer represents the buildup of a single year. In Lake Suigetsu, the first research was done in 1993, when varves were discovered for the first time in Asia. Additional research was also done in 2006 and 2012. Okay, first of all, let's look at how varves form.
In Lake Suigetsu, various substances such as remains of plankton, soil, iron, and yellow sand from the continent are deposited each season, forming striped patterns called varves. Let's take a look at the varves of Lake Suigetsu. We can see alternate light and dark-colored layers. This indicates that each layer, about 0.7 millimeters thick, are the deposits over 1 year.
In the 2006 research, in order to compensate imperfections from the first sediment core sample, the second, third, and fourth samples were combined, and a continuous section of varves with no missing parts was successfully obtained. Amazingly, the varves reflected a 70,000-year time period.
The miracle of Lake Suigetsu, having formed varves for as long as 70,000 years, has taken place with the help of several topographical conditions. The first condition of Lake Suigetsu. The mountains surrounding the lake block winds, preventing waves from building even when strong winds blow, such as during a typhoon. The second condition of Lake Suigetsu. As there are no rivers directly feeding the lake, the water flows gently into it, with sand and mud removed in the upstream lake Mikata. These two conditions allow the sediment to be deposited delicately. The third condition of Lake Suigetsu. The depth of the lake creates a condition at its bottom that lacks oxygen, where things cannot live. This means that the sediment has not been stirred by living things.
With all these favorable conditions together, 70,000 years worth of clear banding about 50 meters thick has formed. It is very rare to have these conditions together anywhere in the world. Lake Suigetsu is exactly the kind of place to be called a miracle lake. Now, let's listen to Professor Takeshi Nakagawa of Newcastle University in England, who was the leader of the Lake Suigetsu 2006 project.
Several places are known in the world for varved sediment that forms layer by layer each year. Findings of such sediment in lakes and shallow seas have been reported. However, there is no other place like Lake Suigetsu, where high-quality varves have been continuously deposited without a break for as long as 70,000 years. And the continuously deposited varve sediment has been researched in such a concentrated manner. So I think I can say that the varve sediment of Lake Suigetsu is the world champion of this kind of sediment. Our research group has counted all 70,000 stripes. By counting them, we have been given an extremely detailed chronological scale for the soil of Lake Suigetsu. Although the chronology determined by counting these stripes can only be used for Lake Suigetsu, we thought of a method to apply it to other locations. We used a conventional method known as radiocarbon dating. However, just using it in a conventional way caused significant inaccuracy. So we paid attention to the fact that the soil at the bottom of Lake Suigetsu contains a lot of fossil leaves along with the striped patterns. We applied radiocarbon dating to more than 800 fossil leaves and elucidated the entire relationship between the radiocarbon dates and the ordinal numbers of the corresponding stripes of Lake Suigetsu. Accordingly, it is possible to identify to what number varve of Lake Suigetsu a radiocarbon date measured somewhere in the world corresponds. In other words, researchers throughout the world used the number of stripes of Lake Suigetsu that we counted as a geological reference timescale, just like we set our clocks with reference to Greenwich time.
The professor talked about the global standard timescale, but what does it actually mean? Let's take a little closer look. Here's an example. You examined an object dug up somewhere in the world using a method called radiocarbon dating and found out that it contained an amount of something called carbon-14. As it just so happens, the amount of carbon-14 decreases over time. Here, the varves of Lake Suigetsu can be used. As you carefully examined fossil leaves taken from the varves using the radiocarbon dating in the same way as before, you found that the fossil leaf in the middle had the same carbon-14 content as that of the object you dug up. You can identify the age of the varve by counting the number of stripes. So it is possible to identify the age of the object too. As Professor Nakagawa has said, various dating methods have been studied so far throughout the world. Unfortunately, though, they were all considerably inaccurate. On the other hand, using the varves of Lake Suigetsu only has an error of about 170 years, even when dating back to 50,000 years ago. If we convert that 50,000 years to 1 day, this error becomes only 5 minutes or so. As a result, it was decided to use the varves of Lake Suigetsu as the global standard timescale for accurate dating. Now that an accurate standard timescale has been established with the varves of Lake Suigetsu, it's been possible to rewrite archaeological chronology. We now move on to the varve research conducted in Lake Suigetsu in 2012.
The research begins with accurately locating the boring position using a GPS. Once the position has been determined, a derrick is built to begin the research. The research involves lakebed boring. This is difficult work, where a long pipe is pushed into the bottom of the lake, which is about 30 meters underwater. And then the sediment filled inside it is pulled out.
This hole is the entrance to 70,000 years ago. It's really exciting, isn't it?
Finally, the pipe pushed into the lakebed is lifted out. The pipe is filled with the sediment that has been deposited over a long period. The sediment extracted from the lake bed is carefully taken out so it does not collapse and thinly sliced for research.
Let's look at a cut surface. You can see beautiful stripes, right? These are what varves really are. A global timescale telling the history of the Earth.
Examining the varve sediments lead to the understanding of the history of the Earth. Understanding the history means that we have detailed information on what happened and when. Regarding the when, we were able to determine it in detail by counting the stripes and using radiocarbon dating. The other important thing is to investigate the history of environmental changes or what has happened in the past. For that purpose, we are analyzing various types of information, such as fossils contained in the varves, chemical compositions, and colors. Now, let's take a close look at the varves of Lake Suigetsu again. You can learn many things from the varves. Looking carefully, there are portions which are wide or have different colors. There are traces of floods and earthquakes. We can accurately identify when the flood or earthquake occurred by counting the stripes. Furthermore, it is possible to identify the flow and change of wind at the time by examining the type and quantity of volcanic ash and yellow sand from the continent. Fossil leaves and pollens indicate climate changes around Lake Suigetsu. About 15,000 years ago, plants typical to the glacial epoch disappeared from the area around Lake Suigetsu, and temperate vegetation began to appear. Using the varves, which have formed year by year, we can identify environmental changes of tens of thousands of years ago in great detail. This has also led to research into global environmental changes.
The varves of Lake Suigetsu have just begun to tell the story of 70,000 years. All kinds of research in the future is going to reveal even more important facts. I just can't wait.
Studies on the value of the varve sediment of Lake Suigetsu as an extremely detailed record of the history of the Earth has advanced, and its value has come to be recognized globally. So we can expect more researchers to join us too. It is also possible that something we have never even thought of will develop as our research group expands. I really hope many people will give us their attention. I think this lake that strongly attracts the attention of first-class researchers around the world is a treasure of Fukui Prefecture in itself. And I strongly hope the local people will be proud of it. The 5 lakes of Mikata, including Lake Suigetsu, have been registered under the Ramsar Convention as internationally important wetlands with abundant nature. Near the lakes, a number of remains have been excavated, giving us an idea of the lives of ancient people. The 5 lakes of Mikata also provide a valuable heritage for passing the history of Satoyama and the lakes, where people and nature have continued to coexist, on to the present day. Lake Suigetsu, one of the 5 lakes of Mikata in Fukui Prefecture, will continue to serve as a milestone to the future.
チクタク刻んでる僕の部屋の時計とにらめっこしては地球の足跡数えてるどこもない